Once my tablet runs, we will be using non-dimensional variables to get Euler because I totally forgot about that. Um, and all credit goes to Dr. Saintillan and Dr. Zara for teaching me this long time ago. Me forgetting like a doofus I always am. And I did forget certain things about the continuity equation, the momentum equation. Um, Mostly doing it off of memory. So if I make a mistake, then yeah, my memory is dog shit. And we all know it. I keep on making simple mistakes with my memory. Plus, I believe it's mu gradient tau. Okay, we'll do double bar on the bottom this time. And we'll do it like this. And I believe it's like this, and then this. And then we'll erase this one over here. And then we have our Euler's equation. Okay, with Euler's equation, the thing I forgot to do last time was basically what order of this can we derive from here? And I didn't do that, and my mistake on that part. I should have been showing that off. And this one is U infinity, right? It has a scale of U infinity, right? And has a scale of density infinity too. But what is time? Time can be personified as well, velocity is meters per second, right? And which is length scale times t, right? Time, right? So move that t up, and we have L over U infinity. I hope I did it correctly. And then we have, did I do that correctly? Um, yeah, because that would give me U squared and a length scale over here. And then this over here obviously has a U infinity square and a density infinity and L square. What I forgot to mention is basically these two have the same order. I don't know how I messed this up. I don't know how I messed this up in another video, but yeah, I forgot about that entirely. So yes. And this another thing I did forget to do was notice that pressure doesn't have what's the right word? A measure yet. You can't really measure it yet. I mean, I already knew that, but I didn't know why, kind of. I knew why, but indirectly, like I can't you'll see what I mean. And over here we have another order over here, which is mu with a tau, which not tau, this is v. So it's I think I did this wrong. Yeah, I definitely did. It's supposed to be like this. Now this time will be u infinity with a length square like this. What this allows us to do is get the Creep/Stokes equation and the Euler equation. So I guess we should also talk about Creep slash Stokes this. We should talk about that too. I didn't think I forgot to do that, I guess. Now we should non-dimensionalize this. And when you non-dimensionalize this whole thing, you can do it yourself, but I'll just really quickly just do it because I'm gonna do the final result because it, it's not hard, but it's just kind of takes forever. But once you do it, you remember it because it's super easy. Because I don't remember the process of doing all of it because it actually takes forever. But I do remember one thing about it, and which is, oh, I should probably explain the rates, which is u. Obviously, the scale is u over v over u infinity, and time I already told you about the scale, and then the gradient equals to. Oh wait, did I do this right? Yeah. Gradient is length times the regular gradient. Did I forget anything else? I hope I didn't. I probably did, but I'm doing it off of memory, so I'm allowed to make some mistakes, is what I'm going to say, and not question my own judgment on that one. I should probably do so because I do some pretty dumb things in my life. Over here is, yeah, I got it right. Okay. Gradient star square, and then plus v dot. Okay. Oh no, please, brain, let's not make the mistake of doing get cross-tabulating the two notations. Stick with one notation, please, brain. I don't want another case of 300 different notations I have because I will do that eventually. That I know for a fact I will. But as you can see with this thing, we realize that this is super big. This goes to zero, leaving us with the Euler equation. And this with the other ones is called Euler equations. Next, with the creep one, you basically get rid of this portion because of what you need to realize, because of how pressure doesn't have any definable units or any scales you can give it, it's just P. You can just give it, you can have it as this for this one. Let me see if I can write it correctly without looking at the scales. And why am I trying to do that is because recently there's well, it's generally a good idea, in my opinion, to be able to do it kind of without looking sometimes because you're studying, you're not actually doing a real whatever. And you hopefully is so in tune to your body that your brain just automatically thinks of the whole thing is my goal. Um, and as you can see with this one, I think I have it mostly down. Anyway, this goes really small because RE goes to really small. Therefore, this goes to nothing, and we have Stokes equation. This is going to be a short video, not very long, purpose, because I just wanted to show these two off because I totally forgot about them, and we're going to stop here.